Hey, this is John at Wells-Tronics 3D. Today, I wanted to show you our reverse engineering process. So far, we've shown a lot of our 3D scanning capabilities with our metrology grade 3D scanning. And the next step in our process that we offer for a service is the reverse engineering portion of this. We, as a company, we're a product development company. We do 3D printing, patent drawings, 3D scanning, 3D modeling, reverse engineering. And today I wanted to focus on that reverse engineering portion of this service. So here, what you're seeing on the screen is we've already 3D scanned this. This is a golf club of some sort that we 3D scanned, and we've imported this into SolidWorks. We have the scan data in SolidWorks, and what we're going to do is we're going to reverse engineer this and build this geometry in SolidWorks so that we can get a CAD file for machining, molding, thermal forming, sheet metal stamping, whatever the manufacturing process may end up being. We're going to create that CAD file so that it's capable of actually being manufactured. So what I have on the screen here is the actual graphic from the 3D scan. This is dimensionally accurate. And what we're going to do here is I'm going to show you how we rebuild this. So what I just did there is I turned on the feature. We created a lofted feature here with some basic guide curves and geometry. And you can see what I'll do is I'll turn the actual solid body a specific color so that you can see the difference between the scan data and the actual reverse engineered part. So now what you're seeing is the red part is the designed part that we are creating. It's the reverse engineered design, and the gray area or the blackish area is the scan data. So what we're going to do next is we're cleaning up this surface here, then we're going to add some rounded edges. You can see these edges became round. We're going to now create this rod that's the shaft of the golf club, and you can see that we're getting pretty close. So now one of the things that we look for is, as we're doing this, is the more surfaces that we can see as we zoom in and zoom out. So you can see here, that means we're getting pretty close with the data. And with our scan data, being that it's metrology grade, we do capture a lot of detail. So some of this stuff, if this club has been used, it could be bent, it could be dented, it could be deformed in some way. So some of that, you will capture that in our scanning process, and we smooth that out. We work around that stuff as we're designing. So here, what we are creating now is we're actually creating the part that we want to build around in this. And as I pull these features down, you'll start to see this part here, this gray part, is what we're actually going after. The red part is just something that we created to be able to redesign so that we can build this gray part. So the gray part is actually a scoop for this golf club. And you can see as we're going forward, we are starting to create a few more geometries. And eventually, as we go through this, what you're seeing is we're creating a clip for this gray part that's going to clip around the shaft of the golf club. And then we're going to 3D print this so that we can test it. So the last part, what we're doing here is adding some fillets, rounding everything, making it look nice. And then we are removing it so that we can see the actual reverse engineered club again. And we'll bring it back so you can see how everything clips together. So what you're seeing here is this part, and this was tested. We 3D printed this, snapped it on the actual club. It worked perfect. Stays in place, and it works exactly the way that it's supposed to. So this, again, this is a very quick version of how we reverse engineer parts and products and create parts and products. But the important part here is you can see that we actually use the scan data. So if we had to try to guess what this angle is of this shaft using a protractor or some other measuring device, taking some stencils with some cardboard, whatever you want to do, take a picture. I've seen people take pictures in SolidWorks and then import the picture, and that can work. It's a bit of a guess, but it does kind of work. But we don't guess. We actually reverse engineer things based on actual CAD data, and we do that with our 3D scanning process, and then we bring that into SolidWorks so we can reverse engineer the actual dimensions and check things. So along the way, we also take calipers, we do physical measurements, micrometers, that type of stuff, pin gauges, and we will actually physically check and compare scan data to physical parts so that things do actually line up on the first try. So with this, what we did, this gray part, we 3D printed it. It came out almost perfect the first time. We made a small adjustment down here to make sure that this surface was continued to be higher than this surface. So other than that, everything looked good. So that's the reverse engineering process, and we can do this with things as small as a dime. We can do it with things as large as 8 feet by 8 feet by 8 feet. Our 3D scanners are able to capture that size of part in anywhere in between. And from there, we bring it into SolidWorks and we start building around it and or build something to the exact shape that we scanned. So again, this is our reverse engineering process. If you or someone you know is looking for reverse engineering, look us up. We can 3D scan it. We can provide you the 3D scan data. If you can't or don't want to or don't have the ability to, then we would do it here. We would reverse engineer the part, create step files, Parasolid files, IGES files, anything that can be imported into professional manufacturing software we can create. So again, look us up online, wellstronics3d.com, 612-587-2812. Thank you.